Okay, can you see my slide now? Everyone?
Yes.
All right, good. All right, so I already described last week, okay, when to use this PLS structural equation modeling. So PLS structural equation modeling is meant for analyzing relationship. Okay, when you create a model, sometimes the model can be for looking into differences or looking into relationship. So this particular software supports what we call structural equation modeling analysis, and it's meant for looking or analyzing on the relationship between variables. So there are two steps involved. The first step is development of measurement model, and the second step is on the assessment of structural model. So you will start with measurement model followed by the structural model. So in the measurement model, you will evaluate two aspects. The first one is called the convergent validity, and the second one is called discriminant validity. First one is called convergent validity, and the other one is called discriminant validity. Now, what is meant by convergent validity? Convergent validity means how good are all the items measuring the construct. How good are all the elements, the item, the indicators measuring the construct, measuring the variable. Now, look at this diagram here. All right, we have drawn this in our SmartPLS last week. Now you can see, look at my mouse pointer. Okay, I'm showing on information quality. So these are called latent variable. Okay, latent variable. So this information quality has got several items. Okay, as you can see here, 1, 2, 3, 4, 5, 6, 7 items. So 7 items are being used to measure information quality. As for system quality, there are 1, 2, 3, 4, 5, 6 items. 6 items to measure system quality. Just now I said in measurement model, there are two assessment. The first one is called convergent validity. So convergent validity is about how good all these items, okay, like here there are 11, 1, 2, 3, 4, 5, 6, 7. How good are all these 7 items in measuring information quality? Okay, how good are all these 6 items in measuring system quality? How good are all these 5 items in measuring security? Okay, so that is meant by convergent validity. Okay, now in assessing convergent validity, there are 4 criteria assessed and reported by SmartPLS. 4 criteria. The first one is called the Cronbach alpha. Okay, the first one is called Cronbach alpha. The second one is called row A. Number 3 is composite reliability or CR, and number 4 is called average variance extracted. Okay, so there are four aspect of assessment to measure convergent validity. Okay, however, out of the 4 types of measurement, okay, normally only 2 are mostly used and reported in journal article or in thesis. Normally only 2 are reported, which are composite reliability and average variance extracted. Now, composite reliability, or the acronym CR, all the values should be above 0.7. All the values should be above 0.7. Now, the guideline is shown here on slide number 17, 18, and 19. Okay, slide number 17, 18, and also 19. Okay, so it is shown there. That is for the criteria, or what we call the benchmark value, the required value for the composite reliability. So the value should be above 0.7. Now, what if the value less than 0.7? Now, if the value is less than 0.7, it means that some of the loading, some of the items here, example, if let's say information quality, the CR, composite reliability, is less than 0.7, it means that some of the item has low factor loading. What is meant by factor loading is the score written on the arrows. All these scores are written on the arrows. These are the factor loading. So now, if the factor loading is low, if we say low means what is the value? The value depends. Okay, the value can range between 0.5 until the value can be between 0 to 1, but of course the acceptable value should be above 0.5. Ideally, the value must be 0.7, ideally. But sometimes, some items have got very high score, like 0.8, 0.9, 0.89. And then you have got 1, 2 item, the score is like 0.6, 0.5. And then when you take the average, the score is still 0.7. So that means no issue, even though the value is 0.5 or 0.6. As long as the CR is 0.7 and above, it is considered valid and reliable. Now, what if the score is less? If the score is less, means some of the items here are low. As you can see on slide number 27 here, it is shown in red color. Where do you go? You go to these outer loadings. So you go to these outer loadings, you have to remove this low item. So when you remove, okay, the best way is to remove one by one. So you remove one and then you run. You remove the other one, you run. So when you remove this item, it is expected that the score of the CR will increase. That means the CR from being red in color, which shows the value is 0.7, the color will change into green. Okay, so that is meant by composite reliability. Composite reliability. Now, average variant extracted, that is another criteria for measuring convergent validity. So average variant extracted, the required value should be 0.5 and above. Now, the deciding factor whether the value, this value is just like CR, fully dependent upon the score of the items. Now, if score of the items are low, example like here, system quality, if some of the items are low, such as 0.4, 0.3, so you can expect that the AVE also will become low. So when the AVE is low, so you have to remove some of the item. Okay, now you can remove items with low factor loading with the hope that CR and AVE will increase. But make sure when you remove, you don't remove until the item become 1. That means the remaining item is only 1. So that is not acceptable. Because now, for example, here, let's say security, the CR is 0.3. The AVE 0.2, it is very low. So you remove the lowest item, you remove one by one until finally you got one item only. So if you have got one item only, you cannot measure CR or you cannot measure the AVE. You cannot measure CR nor you can measure AVE, because in order to measure CR, composite reliability, and to measure average variance extracted, you need to have a score, you need to have at least 2 items, okay, 2 observed variable. Remember the term used in PLS, they call it observed variable, the yellow boxes, the yellow rectangle. All right, so that is convergent validity under measurement model. So we are still not done with measurement model now. So how good are all these yellow rectangle in measuring the green latent variable is called convergent validity. Okay. Another aspect of this measurement model is called discriminant validity. So the word itself is self-explanatory. Discriminant means difference. So it means that how differ is this information quality against system quality? How differ system quality compared against this variable security? How differ is this security compared against ease of use and the rest? Okay, so that means they are comparing the differences. So in SmartPLS assessment, it is expected that all these latent variable should be different. They cannot overlap. Overlap means they are almost similar. They cannot overlap. So they have to be different. So in order to measure that difference, we will look into what we call the discriminant validity, and there are two criteria used. The first one is called the Funnel and Laker assessment. Funnel and Laker assessment. Now, Funnel and Laker I have shown in my SmartPLS output last week. It's here also in the slide. Okay, so you click on discriminant validity, and then you can see Funnel and Laker. Now, what you need to see is that the topmost value on every column. So this column, you look at the topmost value. You look at the topmost value. You look at the topmost value. Now, the topmost value, that means on the topmost cell for each column, the value should be bigger compared on the remaining value on the same row and also on the same column. For example, this value must be bigger than other value underneath and other value on the left. This value must be bigger against other value underneath and bigger compared against other value on the same row on the left. So that is what we meant by this value should be bigger as compared to the rest. Now, what if the value is not bigger? Now, if the value is not bigger, example is one, privacy. 0. Let's say 0. It is 0.600. Now, if it is 600, meaning it is smaller compared to trust. It means that it is smaller compared to trust. So what does it mean? It means that you go here, you go look into privacy, and you go into trust. Some of the items here, and here are actually, some of the items are actually overlapping. How do you know? Okay, now you can know that because you can look at the correlation value where, okay, now what you can do to solve that issue, that problem, is that you have to delete, okay, you have to delete some of the item, okay, some of the item from here or from here, from trust. Okay, you have to delete some of the item either from trust or from privacy. Okay, you just delete one of the items. Okay, try to delete the lowest one. So when you delete, okay, then normally you will have you can solve the problem of discriminant validity. Normally the value of that AVE square root, okay, what do we mean by AVE square root? Actually this value, all the topmost level value, actually the square root of the AVE. Okay, remember this one, AVE, sorry, not this one, this one AVE, the square root. So the square root is this one. Okay, so this is one criteria. Another criteria is to use what we call heterothread monothread, HTMT. Okay, now there are two options. One is Funnel and Laker, the other one is heterothread monothread. Okay, now Now, heterothread, monothread, okay, you will be presented with this table also. Now, look at all the cells, okay, and make sure none of the value are greater than 0.85 or 0.9. If any of the value is greater than 0.85 or 89, normally it will be in red color. So if there is no red color, that means no issue with your discriminant validity. Now, should you report both? Now you can report both, no issue. Okay, or you should report one only. Now you have to choose which one that is favorable to you, which one that is really helping you. Okay, now if you analyze using Fonet and Laker, no issue, then it is sufficient to report Fonet and Laker. But if you report Fonet and Laker, there are issues. And then when you look into heterothread, monothread, no issue. Then you choose the heterothread, monothread, HTMT. But if both have got no issue, then it's fine to report both the Fonet and Laker criterion or the heterothread, monothread, or HTMT. Okay. So far, is there any question with regard to the measurement model? Are you all clear, everyone?
Yes, betul.
All right.
Yes, Prof.
What about the rest? Okay.
Okay, Prof.
Yeah, okay, Prof. Clear, Prof.
Okay. Okay, good. Okay, so now the measurement model, okay, you have to complete. Not only complete, you have to fulfill the requirements. What requirements? The convergent validity requirements and measurement and the discriminant validity requirement. These two requirements must be fulfilled. Once you have fulfilled these two requirements, then only you will proceed to the next stage, which is called the structural model assessment. Now, structural model assessment is also called the hypothesis testing. It is also called hypothesis testing. Now, you cannot proceed to hypothesis testing if your measurement model is not settled. It's not settled means what? Your convergent validity did not fulfill the CR requirement or the AVE requirement. Okay, your discriminant validity also did not fulfill the requirement. Okay, so you have to solve that measurement model, then only you can proceed to the structural model. Now, what happened? Let's say in the measurement model, you try your level best and still you cannot fulfill the requirement. All the values seems to appear in red, meaning to show there are issues, there are problems. You have tried all alternatives and it seems that you are in a deadlock, still you cannot solve. So can you proceed to the structural model? No, you cannot proceed. Meaning to say, forget about testing the hypothesis. There's no way you can use structural equation modeling. So how do you do that? So how do you proceed then? So probably you need to use multiple regression. That is to use the SPSS software. Okay. So you have to analyze using multiple regression, not with the structural equation modeling, that is to use the SmartPLS. Okay, now let's look into our SmartPLS. Hang on, I need some time to show my where is my SmartPLS? It's not appearing. Okay, can you see my SmartPLS, everyone?
Yes.
Okay.
Yes, Prof.
All right. So remember, let's rerun again in case you have forgotten. Once we have drawn, just repeat. We have done this last week. Okay, you click on calculate, and then you click on PLS algorithm. Okay. Okay. Last week we had like 365 items, so you put 365 and then you click start calculation. Okay, so you will get the output. So you look at construct reliability validity. This is where you see the Chromebug alpha, row, composite reliability, average variant extracted. Okay, now for reporting also you can show the graph if you want. Okay, you can just click here on the graph. Okay, see, you can see the graph all are in green, and you can see this line 0.7, that is to show the benchmark. So you can just copy to clipboard, click, and then you can paste onto your Word, okay, for reporting. Same goes for the row, the composite reliability, and also average variance extracted. Okay, so it's good to include the graph because as the dictum says, a picture is worth 1,000 words. Okay, it's more clearer. All right, that is the convergent validity. All right, as for discriminant validity, you click on that tab. Okay, and then you can see this output, Fournette and Lacker criterion. So how are you going to take this table? You just click on Excel format, you paste on your Excel. From the Excel, you copy and paste onto your Word. So the whole table, So you just say if all the values, you say all the values are above other values, then discriminant validity can be assumed. Okay, if you want to copy the heterotrait monotrade, okay, this is the one, heterotrait monotrade. So you can claim here none of the value is less than or is bigger than 0.85 or 0.9. So discriminant validity can be assumed. All right, now even this diagram on this diagram also, which we have drawn, you can also copy and paste onto your Word. What you need to do is that you just on your menu bar, you click File, and then you can click on Export as image file. You click there, and then you can save onto your file directory, and then later on you can retrieve and you can paste onto your Word file for reporting. All right, so this is the measurement model. So once we are done, we are going to proceed with the hypothesis testing. So this is called the structural model assessment. Structural model assessment. Now, how are you going to proceed with that? So here you are going to click calculate. Okay, are you going to do together with me, all of you in front of your computer?
Yes.
What about the rest? Are you also having SmartPLS in front of you?
I think I want to concentrate looking at your slide.
All right.
Then I will try later.
What about the rest?
Saya tengok dulu doktor sebab saya dekat office doktor, tak bawa laptop satu lagi.
Okay. Syarul Aimi? Where are you? I can't hear you.
Hello.
Oh, I cannot hear you. No. Is my voice okay, everyone? Can you hear my voice clearly? I'm worried that you can't hear.
Clear.
Clear.
Okay. Because after listening to Syarul Aimi, I'm worried that I'm also having that problem where you cannot hear my voice. Okay, now what you can do is that on your menu bar, you click calculate. Click calculate, and then you can see you will be shown with several options. You click on bootstrapping. Bootstrapping. Okay, click on bootstrapping. All right. So now, once you have clicked that bootstrapping, this pop-up window will appear, and you have to you have got several options to click. Okay, you have got radio button. The one that you have to focus is this one tail, two tail. Okay, one tail. Okay, just click on one tail, one tail. All right, so click on one tail and then you start calculation. Click on start calculation. Okay, it will take some time. Okay, okay, that's it. So the output will be shown to you. All right, so now this is the output. Okay, this is the output. Now you can also look at the output on the diagram itself. On the diagram itself. Okay, so you can look at the output here. So let's hide all the observed variable or the item. We want to hide. We just want to see. You right mouse click and then you can hide. Okay, so that it is clearer for you to see. Okay, I'm gonna hide. All right, so here I'm going to arrange nicely. Okay, now all the values on the line, on the arrows, all the values are actually, when you click on this bootstrap, are actually the T statistics. T stands for T, tengok lah, tatap, tenung, tengok. That is the meaning of T. Okay, in case you forget. All right, so T means tengok. You have to tengok that T lah. T, so these are actually the T. Okay, written on top of the arrow. Now, the T should be above 1.645. Now, the T, when it is above above 1.645, it means to say that the hypothesis is supported. Okay, so it depends on how you hypothesize. Now, if you hypothesize to have a positive, like in this case, all are being hypothesized as having positive relationship. All are being hypothesized to have a positive relationship. So in this case, you can see all are in positive. There is no negative value. Okay, so and all of the values are above 1.645. When it is above 1.645, we can make conclusion that all the hypothesis is supported. Okay, sorry that I didn't write the hypothesis, but the hypothesis here, more or less, information quality has a positive relationship with ease of use. So here, the T is 3.0.6, so we can support the hypothesis. Same as for the rest. So all hypotheses in this case are supported. Okay, now what if the now let's say you hypothesize to have a positive, but then all the scores or some of the scores do not exceed 1.645. Now, if the scores do not exceed 1.645, it means to say that the hypothesis is rejected. Okay, now can I have my results where all hypotheses are rejected? Okay, that is something very rare. Okay, if all the hypotheses are rejected, something is wrong somewhere, probably in your measurement, probably in your questionnaire. Okay, the choice of respondent, participants, okay, not suitable. Okay, because you develop the framework and then you create the questionnaire, you distribute the questionnaire to the respondent with the hope that the data you obtain will support you. But if the data that you collect all, instead of supporting you, rejecting you, it means something is wrong somewhere. So it's not possible, very rare. Okay, at least we have to have few relationships supported, few hypotheses supported. If all are rejected, something is wrong somewhere. Okay, probably in the development of the framework itself. Okay, or probably in the measurement, in the questionnaire, or the choice of respondent. Okay, so How are you going to report? So you are going to report by copying all this table. So this table you copy, okay, Excel format, you copy, put on your Excel, and then you will highlight all those relationships that are relevant only. Okay, you just Excel format, and then you see the relationship that are relevant. Those arrows or those relationship that are not in the hypothesis of your study, you just reject, you just remove or eliminate them from the table. All right, so this is the table that you have to report. Okay, the next thing that you have to report is the R square. R square. So where do you get the R square? R square, you will obtain the value from the measurement model analysis, the previous one, PLS algorithm. This one, okay, you can see R square. R square. Now you click on R square, okay, and then you can see the value. Now what do we mean by R square? R square is actually here. When you click here, your framework, okay, R square is actually, okay, in a model of the model. Okay, R square, you look at here, the dependent variable is trust. This one, ease of use, satisfaction. They are also dependent to this information quality, system quality, security, and also privacy. Okay, they are also dependent to this for independent variable. Okay, R square means how good are the independent variable in predicting the dependent variable. So that is meant by R square. It is called predictive power, predictive relevance. So here, the dependent variable are ease of use, satisfaction, and trust. So here, you need to know what is the R square of ease of use. You need to know the R square of satisfaction. You need to know the R square of trust. Okay, so the R square must be, if possible, try to be above 0.3. If not, at least the R square must be or should be above 0.1. Okay, so here in the output, you can look here under PLS algorithm, R square. Look here, R square for ease of use 0.488. So it is more than 0.3, which is good. Satisfaction, it is above 0. It is also good. Okay, satisfaction 0.56, above 0.3, it is also good. Trust above 0.3, which is 0.4, it is also good. So that means to say, it means that all these four independent variables have strong power to predict ease of use, have strong power to predict satisfaction, and these two variables, ease of use and satisfaction, these two combined both have strong power to predict trust. Okay, now what if your value of R square is less than 0.1? Okay, if you look at this score, okay, the value is, let's say, 0.02, okay, 0.02 or 0.03 or 0.09. Basically, it is less than 0.1. So if it is less than 0.1, it means that even though your hypothesis is accepted, that means the independent variable, okay, the predictors independent variable are not very strong in predicting the dependent variable. That means they are actually significant, but they are not very strong. They are not very strong to actually predict the dependent variable. Okay, that is R square. Okay, R square. The next one you have to look into is what we call the Q square. Q square is also similar like R square. Q square is also similar like R square. Okay, let's look at my slide. Okay. Oh, I missed one thing. It's about the collinearity. Collinearity. I missed one thing. Okay, I'll revert to that later on. I just proceed with the R square. Okay. All right. Okay, the next one is called Q square. Q square is another measurement equivalent to R square. So how do you get Q square? You click on calculate and then you click on blindfolding. Blindfolding. Okay. Okay, so omission distance, this one 7, leave it as it is. Okay. The theory is given here, why it is 7, so you can read by yourself. And then you just click start calculate. Okay, now the value of Q square. Q square is also similar to R square. It is called predictive relevance. Okay, predictive relevance. Now Q square is also similar like R square. The value of Q square must be above 0. Must be above 0. That means any value above 0, 0.3 or 0.1 or even 0.001, as long as Q square is not 0, meaning to say that all the IVs have predictive relevance, okay, have predictive power to explain the DV, have predictive power to explain the DV. All right. Now, another aspect is of use security. Okay. All right. So another thing is the F square. F square. Now F square, this is about effect size. Effect size means probably because of the sample size is too big, and then by chance you get some of the hypothesis supported. Okay. Here, as long as the value is not above 0.3, no issue. Here the biggest is 0.289, so it's not bigger than 0.3, so it's not an issue. So don't worry about this F square. Now for PhD, I think you have to report. For the masters, it's fine. I think if you don't report, also fine. Okay. So so basically we are done with the basic structural measurement, structural model measurement. After we have done the measurement model, we have completed with the structural model assessment, that is hypothesis testing. So let's recap. How do we do the structural model assessment? We do the structural model assessment by clicking the calculate. Calculate, you click on blindfolding. Sorry, not blindfolding. You click on bootstrapping. Bootstrapping. Okay, and then you choose one tail, click start calculation. Okay, then you will get the output. You look at the path coefficient, make sure the T here, you can also look here, make sure the T all are above 1.645. It is above 1.645, that means the hypotheses are supported. Okay, so next one, you have to look at the predictive power of the IV against the DV. So how do you do that? You look at the PLS algorithm, look at R square. The R square for the DV must be above 0.3. That is one thing. Another thing, you have to run the blindfolding. Blindfolding, you click on calculate, you click on the what you call blindfolding, and then you run. And then when you run, you will get the output. Make sure all the values should not be 0. Okay, should not be 0. Basically, should be above 0. As you can see here, above 0, so no issue. So Q square and R square both are about predictive power. How good are the IV in predicting the DV? Okay, just now I said I missed one thing. That is the VIF. VIF means the variant inflation. Collinearity. What do you mean by collinearity? Is collinearity more or less like discriminant validity, whether this and this overlap or not, whether this and this overlap or not, whether this and this overlap or not. So this one you have to check first before you run the structural model, which I have forgotten to mention just now. Okay, after you have completed the measurement model, you have to proceed to the structural model. But before you proceed to the structural model, you have to check on the VIF, variant inflation factor. Okay, now that can be seen in your PLS algorithm, and then you can look in the collinearity statistics VIF. Click here, and then you click on inner value. Now you can see none of the value here is above 3. Okay, now if the value is above 3, now some lenient reference say should not be above 5. Okay, so you can refer either 5 or 3. Okay, if it is in red color, that means it has got some issue. Issue means what? They are overlapping. So if they are overlapping, now let's say here privacy and satisfaction. Okay, privacy and satisfaction, sorry, the satisfaction and trust. Now let's say satisfaction and trust, the value is 6.00. Okay, look here, privacy and trust. Where's privacy? Privacy and trust, the value is so big, so that means they are overlapping. So meaning to say, you have to remove privacy. You have to remove privacy from the model. Even though initially in the measurement model it is fine, but because of the collinearity issue, so you have to remove. Now, what if you do not want to remove? That also can be done, but when you report your findings, you have to caution the reader about the limitation of the study. You have to mention that in this study there is a collinearity issue. Collinearity issue means what? Privacy and trust is overlapping. Okay, so far, is there any question, ladies and gentlemen? Are you all clear?
Prof, I would like to ask about the T statistic.
Yeah.
If my hypothesis is negative, the number should be negative 1.645.
Yeah.
Okay.
If you hypothesize the relationship to be negative, so the value also must be negative, and the negative also must be above 1.645. Is that okay, Umi? Understand?
Yes, Prof, understood.
Okay, so if the value negative and you hypothesize negative, so you can make conclusion that hypothesis supported. Now, what if the value become positive? You hypothesize to be positive. The value is negative, and the value is negative 3.00. Still, your hypothesis rejected because of the different signage. You hypothesize positive, but the output negative. So you still negate, you still reject the hypothesis. Is there any other question? Okay. Akmal, Faiz, are you still around?
Yes, Doctor.
Okay, good. Huh? Dayang, is it okay, Dayang?
Yes, Prof. Okay,
Good.
Doctor.
Good. And Naim, is it okay? Naim gone. Gone to
No.
Dhaka, Bangladesh.
No, Doctor. Actually, it is software I cannot install. That's why. I'm noting in my hand.
Don't worry, Naim. You are not going to use the software this semester. Just try your level best to grasp whatever knowledge. Now, please be reminded, all of you are not going to use this software this semester. You are going to use when? Aizat, when are you going to use the software? Aizat, are you still around or you already fall asleep?
Yes, I'm still around.
When are you going to use this software?
Actually, I'm using the software actually.
I cannot hear you. When are you going? My question is, when are you going to use this software?
After doing my research, I can use the software actually. Doctor.
Yeah, that's correct. You are going to use it next semester, not this semester, okay? So, but I have to teach because next semester you don't have the opportunity to learn. This is the time where you learn research method. Okay? Going to ask. Yeah. Ask Kak Abi. Yeah, what question? Anybody
Okay.
want to ask question?
Next semester, can we actually
Yeah.
ask?
I cannot hear you.
Okay. Hello,
I
hello.
cannot
Can
hear
me
you,
now?
sorry.
Can you hear me now?
Yeah.
Okay. Next semester, if we encounter any problems, can we actually ask?
Sorry, I cannot hear you, Razman.
Okay. Can you hear me now? I don't know what's my mic.
Okay. Yeah. What?
Okay. Next semester, when suddenly we encounter any troubles, can we actually liaise with?
I didn't get what you say. You mean you have problems in case you have problem? So you want to refer to me?
Yes. Okay.
No, you don't have to refer to me. You can refer to some other students. You can refer to your other lecturer. You can even refer to your supervisor. You have been assigned with the supervisor. Your
But you are
supervisor should help
expert.
you.
But you are expert in this. I noticed you are very good in this.
No. You should refer to your supervisor. I will be the last person you should be referring to. Because you have to know that I have got other students to entertain also. Not only my students, other students. That's why next semester you will be assigned with supervisor. Unless you are under my supervision. Okay, normally I entertain.
Okay, no problem.
Okay. But if you still stuck, you can always join my class. You can see some of you here are not registered in the class, but I invited. No issue. Okay. Can we continue, everyone?
Yes, sure, Doctor.
Okay. Some of you I cannot hear clearly. I don't know what happened. Is it because you are in a car traveling or using your handphone? You see, I can't hear you. Some of you try to speak, but I cannot capture the words clearly. And I'm worried whether you can really listen to my voice or not.
You are clear, Doctor.
You can speak clearly. For me, it's no issue. But the rest, quite problematic. Okay, now, if you look at this diagram, okay, slide number 41. Now, if you look at this diagram, ease of use and also, can you see my slide? Are you looking at my slide? No?
No, Prof.
It's not my slide, is it? Okay.
The PLS.
I will change PLS, yeah? All right, now if you look at the slide, here, ease of use and also customer satisfaction is placed in between these 4 IVs and this 1 DV, correct? So these are actually what we call mediating variable or intervening variable. Mediating variable or intervening variable. Okay, now sometimes in your research model, you have framework such as this. Okay, you have variables that sits in between 2 variables. Okay, now, do you really have to hypothesize as mediation? Now, it's up to you. It's up to you to decide. If you want to hypothesize mediation effect, you can. Now, if you do not want, also can, no issue. Okay, because it is not compulsory. But if you want to add on having additional hypothesis that you want to see the mediating effect, so it's fine. But make sure the model must have variable that sits in between. Okay, now let's say you want to see whether these two variables, which are ease of use and customer satisfaction, whether these two are really mediating effect or not, whether they are really mediators. Okay, so now we are going to look into this. Okay, we are going to do the analysis. Okay, actually you don't have to run anything, you have already run, you just have to look at the output. Okay, but never mind, I'm going to show again how are you going to do that. Okay, hang on, I will change the slide into SmartPLS. Oh, where's my SmartPLS? All right, so you run again. So ease of use and customer satisfaction. So we want to know whether these two are really mediators, whether they are truly mediators. Okay, you just click calculate, and then you click on bootstrapping. You run as usual, as how you run for structural model. Okay, so then you look at this specific indirect effect. Okay, specific indirect effect. Okay, specific indirect effects. You look at that, and then you can enlarge on these. Can you see my SmartPLS screen, everyone? Can you all see?
Yes.
Okay, so you click on specific indirect effect, and then you can see here information quality, ease of use. Okay, and then trust. So is it mediate? Now you look at the T statistics. Yes, because it is above 1.645. So that means ease of use mediates the relationship between information quality and trust. Okay, ease of use, is it mediates between privacy and trust? The answer is yes. So basically, if you look on the rest, all are above 1.645. So meaning to say that, okay, meaning to say that all these ease of use and satisfaction, these two variables are really mediating the relationship between these four and trust. So that is mediation effect. So you don't have to run anything. You just look at the output that you have already done, but you just have to click that option, what do you call, in the output, you under bootstrapping, you click on specific indirect effect. Now, if you are using SPSS, this process for determining the mediation effect is quite cumbersome, it's quite difficult. But in SmartPLS, it is so easy. So easy, because you click and then you will get the output. All right, so we are done with mediation effect. Okay, so the next one we want to look into. So can you understand mediation effect, everyone?
Yes, Prof.
Yes.
Good.
Yes, Prof.
All right. Now we want to look at what we call moderating effect. You can look on your slide number 44, moderator effect. Okay, moderating effect.
Prof, are you showing your slide right now? Because I see the SmartPLS.
Okay, I will show in the SmartPLS. Okay, so now you can look at the same time, you can also look at your slide. Your slide is on slide number 44. Slide number 44. Okay, can you see slide number 44? Now assuming there is a moderator. Okay, if you look at slide number 44, okay, I'm gonna show the slide, because I'm worried some of you are not opening the slide, so you cannot understand what I'm trying to say. Okay, can you see my slide now? Can you all see, everyone?
Yes, Prof. Can, Prof.
Okay, all right. So you can see, assuming in your model you have gender as moderating. gender that sits in between ease of use and trust. Can you see on my slide, gender? Remember, moderating effect is a variable that is connected to another arrow. So basically, it controls the strength of relationship between two variables. Like in this case, ease of use is the IV, trust is the DV. So gender sits in between. So gender controls or moderates or regulates the relationship between ease of use and trust. So we want to check now whether gender is really moderating the relationship between ease of use and trust. So to do that, we are going to analyze using SmartPLS now. So I'm going to show you. Okay, I'm going to show you. Hang on. All right, so I'm going to put gender here, indicators. I'm going to take genders. I'm going to drag and put it here. All right, so gender, I'm going to rename this one gender. Click OK. All right, so the next thing, you click on this arrow on your menu bar, you connect to this trust. Now you cannot connect the arrow to this arrow, cannot. In SmartPLS, you cannot do that. Okay, you cannot what do you call, take this arrow and put it here, cannot. You cannot do like that. Can you see my SmartPLS screen, everyone? Can you all see?
Yes.
Okay, you cannot do like that. You have to connect to the DV. Okay, you have to connect into the DV. Even though this is a moderator, by the convention of diagramming, by right, the arrow should be pointing to the arrow. But in SmartPLS, they don't put the convention like that. So now you have to click on trust. Okay, click on trust. And then you right mouse click, you put the add moderating effect. Add moderating effect. So another arrow will appear. So your moderator here is actually gender. Okay, independent variable is of use. And then you click on product indicator. Product indicator, and then you click OK. All right, and then you can see the moderating effect. You double click and then you rename. Okay, when you rename, you put there gender asterisk. Okay, gender asterisk with just now is ease of use, right? Ease of use. Okay, gender ease of use. So you can put it here, and then you click run. You click run, and then you click on bootstrapping, and then you click start calculation. Okay, all right, so now you look at this one, gender times ease of use over trust. Okay, if you cannot see on this table, you can also look here. Okay, this one, look at this one. This value is 0.372. Now, because the value is less than 1.645, so you can make the conclusion that gender does not moderate the relationship between ease of use and also trust. Gender does not moderate the relationship between ease of use and also trust. Okay? Is that clear, everyone?
Yes, doctor.
It's clear.
All right. All right. So all this while, what I have shown to you is what we call the first order measurement. Okay, now you can look at your PowerPoint slide. Okay, is first order measurement. Okay, first order measurement. Let me show to you my slide. Okay, can you see my slide, everyone? Can you see my slide?
Yes.
All right. Okay, now I'm going to show you second order. Second order. Now, all this while, I'm only focusing on single order. Single order means you look into
Sorry,
dimension.
Doctor.
What?
Sorry, Doctor.
Yeah.
Doctor, why my slide is different from your slide?
I'm not sure. Is it different, everybody? Is everyone having different slide?
I think
No.
uh the slide number different compared to the one that you share.
Oh, I see.
But it's still in the PDF file that you share.
But can you see this the same thing?
Yes, can, Prof.
Okay, okay. Probably the numbering is different. Dayang, check. All
For
right. So
PDF, for
yeah, the
PDF,
PDF.
it's
Yeah,
page 62.
52. Yeah,
62.
62.
Yes, for PDF.
Okay, okay, okay.
Mine is different, Doctor. 62 also, I couldn't find this exercise second in 62.
Oh. Never mind later on. Just look at what I have here first. All right. Okay. Now, so this is you look at my slide. Okay. Perceived quality. Okay. This has got two dimension, information and also system. And then perceived credibility has got two dimension, security and privacy. And then we have got 2DV, trust and satisfaction. Okay, trust and satisfaction. So now, how are we going to analyze when your model is like this? Then we call it second order. This one, perceived quality is called concept. Perceived credibility is also called concept, or they are called second order. Okay, so I'm going to show you how are we going to do that. All right. Okay, I'm going to open up my okay, can you see my SmartPLS, everyone?
Yes.
Okay, I'm going to
Yes,
duplicate,
Prof.
duplicate, yes, okay. So after I have duplicated, I'm going to delete this one because I'm going to create second order. If you notice just now, information quality and system quality is perceived quality, whereas security and trust is called credibility. Security and privacy is called credibility. Okay, so I'm going to remove all the arrow first. Okay. I think is ease of use is not there. Is what trust and satisfaction. So I'm not going to use ease of use. Trust and satisfaction only. All right. So now I'm going to take. Okay, I'm going to show all the item. Show indicators. This one is show indicators. Show indicators. Show indicators. So here information quality is from 3, 4, 5, 6, 7, 8, 9. Okay. So what I'm going to do, I'm going to take this latent variable, click and put it here. Okay, latent variable, and then I'm going to name it as perceived quality. Perceived quality. I'm going to name it perceived quality. So here the item is what? 3 until 9. So I'm going to take item 3, IQ 3 until 9. This one, highlight, press shift, and then I drag, put it here. Okay, put under quality. And then this one, system quality is from 3, 4, 5, 6, 7, 8, 3 to 8. So I'm going to take this one 3 until 8. Again, and put it here under, you can see a long list, right? So basically all the items here, put it here. So you hide now, hide, hide, and then you take this arrow, connect, connect. Okay, done. Okay, now I'm going to take security and privacy, which is credibility. So click this one, put it here, and then you rename perceived credibility. Okay, perceived credibility, and then security is SEC 1, 2, 3, 4. Okay, then you take SEC 1, 2, 3, 4. 5 is not included. Put it here, and then privacy PRI until 1 until 4. PRI 1 until 4. Put it here. Okay, now you can hide, 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 and then you connect the arrow, connect, and then this one, connect, 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 connect. Okay, so now we have drawn, we have not analyzed yet. So we are going to analyze, put in a proper and clearer location. Click on calculate. First, PLS algorithm, measurement model. Measurement model, look at this one. Okay, all green, no issue. So we don't have to delete anything because everything already green. So no issue on CR, average variance. Okay, and then look at VIF. VIF, inner, okay, nothing, all green, no red, no issue. So measurement model, no issue at all. So you don't have to delete anything. So now we are going to run the structural model. Structural model. Okay, click on calculate, bootstrapping, click start calculation. All right, so look at the T value. Okay, T value, all T here. Okay, look at the diagram. See, all T are above 1.645. So basically, all the hypotheses are rejected. Okay, sorry, supported. Actually, this same model already being published. Okay, I already published this paper based on this model exactly. This is by your senior, one of your senior. He did his master under my supervision. Because the model is good, so I published the paper together with him in a journal, indexed by Scopus. Okay, so this is what we call second order when you have got concept. Okay, if you want to hypothesize when concept. So concept wise, you want to hypothesize when you want to reduce the number of hypotheses. Okay, like in this case, okay, the hypothesis is only this part, not on this part. Okay. All right, so I think for the master students,